We are starting with number 76. 76 says, g is a function. We know 2 points on that function. Which of the following conditions guarantees that there is an x somewhere between -1 and 2 for which g of x is equal to 3? Now, when you hear the guarantees that something exists, it's probably a mean value theorem. If I look at -1, 0 is one of the points, and 2, 5 is another point. And it's asking between x equals 1 and 2, what information do I need to guarantee that somewhere between those x values, we have to have a y value for that g function at 3? What's going to guarantee that that happens? And this is an issue of intermediate value theorem. Because 3 is between 0 and 5, all I need is for this to be continuous. If it's continuous, then it forces it to have at least one x-coordinate in between 1 and 2, for which the y value of that function is equal to 3. Continuous is all we need. '77. For this, you are told that those are differentiable graphs. You've got a function p. P is the multiplication of the two. We want to know which of the following must be true about the derivative p prime. So to find p prime, I have to use the product rule. That's probably why they use the letter p. Product rule says, keep one multiplied by the derivative of the other, plus swap who has the derivative taken and who stays. Now, if you take a look, some of these are looking at p prime of -2. Some are looking at p prime of 0. So these are the two things that I have to figure out. Now, if you look at these functions and you look at the possible answers, we're trying to figure out issues of positive, negative, or 0. So I am going to lasso this and bring it over where I can see it next to the graphs. And I'm going to start with -2 for the x. You can see that the derivative of g at -2 is 0. It has a 0 slope. The y value of f at -2 is 0. So if I'm looking at p prime at -2, then g prime of -2 is 0, and f of -2 is 0. I still need more information. The derivative of f at -2 is positive. Here, the y value of g is negative at -2. So if I multiply a positive times a negative, I will get a negative. 0 plus negative is negative. So do I have a result p prime of -2 is negative? I do. Do we want to double check the issues at 0? Now, looking at that, p prime covers everything with less than 0, greater than 0, or equal to 0. You should know better than to look at what happens at x equals 0. based on this trio, one of them has to be correct. Unless the derivative does not exist, which you can see it's fine. Okay, for number 78, let's highlight. 78. For number 78, we want to know how much oil leaks out of the automobile in the first half hour. We are given the function for the rate at which it leaks. Now, I'll tell you the mistake that I made just a minute ago when I looked at this. I thought, during the first half hour, that's time 0 to time 30. But I found that I got a huge number, and that's definitely not fitting this. So always check, what is the actual measurement? What are the units? T is measured in hours. So if T is measured in hours and I want to integrate the rate at which it leaks in the first half hour, that's going to be 0 hours to 1/2 of an hour. And you'll use your graphing calculator, but this is showing what happens when I solve the integral from 0 to 0.5. I get 0.541. 0.541. $79. Third degree Taylor polynomial for G. Oh, careful there. For G. G is the integral from 0 to x of f of t. So let's be careful. And let's realize what this is saying. The derivative of G must be equal to f of x. This is the relationship that I am dealing with. I'm given all these values pertaining to f. Now, I'm debating whether I want to focus on this one way or another way to get through this as quickly as possible. And so one thing that I can realize is the second derivative of G is equal to the first derivative of x. So let me point that out, and that's going to, I think, be the quickest way to see this. That means this f prime is actually G double prime. Because you want to be very, very careful that you look at the derivative in the correct direction. So I did this work to really get situated with somebody that I could really, actually I could have looked at it here, couldn't I? F of x is G prime. So these are the pieces of information that I have. That also says G triple prime is 2. Oh, this is going to give me G to the 4th, but I don't need that because I'm looking at third derivative. And does it tell me anything? Oh. Haha. Because I actually need to know G of 0, G prime of 0, G double prime of 0, and G triple prime of 0. Those are the things I need to get this. What is G of 0? It is 0. Now, let's let the formula begin. When n is equal to 0 in my Taylor formula, I should probably write this. Okay, when n is equal to 0, I should probably make that a g. I'm getting there. That means what is g of 0 all by itself? And I know that is 0. When n is equal to 1, that is asking me what is the first derivative of g at 0 times x to the 1 power. That would be 3 times x. When n is equal to 2, that's the second derivative of g at 0 divided by 2 factorial times x squared. G double prime of 0 is negative 4. So negative 4 over 2 factorial times x squared. And then when n is equal to 3, third derivative of g at 0 over 3 factorial times x cubed. Third derivative is 2. And I'm trying to match this up with some multiple choice possibilities. Let's see if I got the whole thing. I'll put it here. I'm going to erase the other stuff so it doesn't get in the way. And now let's take a look. Who matches? We've got a 3x that kicks it off. It's between these two. Look a little bit farther, and I'm seeing 2 over 3 factorial is not 2 over 3. It is actually 1/3. C is the correct answer. To number 79, double check. C. '80. Okay, we are given a graph of f prime. We want information about f. Where is the absolute minimum of f? Best way to do this is to chart it out. And that is meaning I want to know where f prime is positive and negative. This is the graph of f prime. Positive and negative, when I look at the graph of f prime, means above the x-axis, below the x-axis. So at 0, 1, and 2, my first derivative is actually going to be equal to 0. I am positive between 0 and 1, and I am negative between 1 and 2. So that means that f will increase until I hit 1, and then it will decrease. Absolute maximum occurs when x is equal to 1. And is that what it asked? No, it asked for the minimum. Ha, ha, ha. Always read the words. Maximum, minimum. Very important. Minimum. And what you want to see is the amount of change from time 0 to 1 that was positive is the area. I added that much area. The amount of change from 1 to 2 is a decrease by this much area. There's a lot more decrease between 1 and 2 than there is increase from 0 to 1. 2 is where my absolute minimum will occur.